In this video, we'll work through how to find the LCM using prime factorization. Now, if you have never heard of prime factorization, I suggest that you stay with the first two methods of finding the LCM. They're both fairly simple and effective. Now, let's see how we can use prime factorization to find the LCM. So I'm going to stay with the two numbers I have used before, 18 and 24. So let me factorize 18. 18 is 2 times 9. And I like to circle my prime factors as I go along. And 9 is 3 times 3. So 18 equals 2 times 3 times 3, which is equal to 2 times 3 square. And if I look at 24, 24 is 2 times 12. 12 is 3 times 4. And 4 is 2 times 2. And 24 is equal to 2 times 2 times 2 times 3, which is equal to 2 cubed times 3. Now the way you find the LCM is you look at each of the prime factors and look for the highest power for each prime factor. Say if you look at 2, 2 to the third power is the highest power for 2. And you know that the LCM is a multiple of 24, so 2 to the third power has to be a part of the LCM. So let me try and use the same colors. And now if you look at 3, 3 square is the highest power for 3. And again, you know that the LCM is a multiple of 18. So 3 square has to be a part of the LCM. And so the LCM is 2 cubed times 3 square, which is 8 times 9, which is 72. And it's as simple as that. Once you have done the prime factorization, you look at each of the prime factors, look for the highest power for each prime factor, and the LCM is the product of the highest power of each of the prime factors. So now let's try and do this for 3 numbers. I'm going to stay with 18, 24 and pick 60 as my third number. So let's see. We already know that 18 equals 2 times 3 square and 24 equals 2 cubed times 3. So let's see what 60 equals. So 60 is, let me quickly prime factorize it here. So it's 2 times 30, and 30 is 2 times 15, and 15 is 3 times 5. So 60 equals 2 square times 3 times 5. And the way I can find the LCM is I look at each of the prime factors and find the highest power. So if I look at the 2, 2 to the third power is the highest power, and that's part of the LCM. If I look at 3, 3 to the second power is the highest power, and that's part of the LCM. And if I look at 5, 5 to the first power is the highest power, and that's part of the LCM. And that is 8 times 9 times 5, which is 360. I really like this way of finding the LCM because once you know how to do prime factorization, it's a fairly simple and elegant way to find the LCM. The other reason I like this is you can now express the LCM in terms of each of your original numbers. For example, the LCM is equal to 18 times, if I look at 18, it already has a 2 in it, so it needs 2 square times 5. So 18, so the LCM is 18 times 20. and it's also equal to 24 times 24 already has a 2 cube in it. It has 1 3, so it needs another 3, and it needs a 5. So the LCM is 24 times 15, and it's also equal to 60 times 2 times 3, which is 60 times 6. So that's pretty neat, the way I can express the LCM in terms of one of the original numbers times another number. And you will find that this is quite useful when you have to find equivalent fractions, or when you're comparing fractions or adding and subtracting fractions. And I'll show this in some other video.